Welcome again in the LIC practical session, online practical session. As we have discussed in the last lecture or the last video recording, we have discussed the practical session on low pass filter. Okay, first order low pass filter. Now today again we are going to see the first order high pass filter. So this first order high pass filter is the reverse of actually the low pass filter. So in high pass filter, actually this is the frequency response for the high pass filter. In this high pass filter, this is a cutoff frequency. So for the lower frequency, the gain is minimum and it will be increased as we go on increasing the frequency. That means this frequency is increasing for this particular cutoff frequency. Beyond this cutoff frequency, the gain is constant and the roll-off rate is plus 20 dB per decade for first order, right? So we know that for first order it is 20 dB per decade. And this is the demo kit for this first order high pass filter. So there is a op-amp operational amplifier which is a 741 IC. It requires supply plus minus 12 volt. Then this is the circuitry of high pass filter. Capacitor is connected here. In the previous case, the capacitor connected was here, right? So this is a feedback network and this is the load, right? 10K load. And we usually we require this function generator and the oscilloscope for getting the output readings. Now what we will do, we'll go on increasing the frequency and see how the gain behaves as per the input frequency, right? See, suppose my frequency is very low now. So frequency, you can see the approximately 700 hertz. For 700 hertz, the reading is 5 volt, right? Output voltage is 5 volt. If suppose for minimum frequency, you can observe for the minimum frequency, let's say for 300 hertz, the output is 2 volt only, right? If I increase the frequency, let's say 500 hertz. See, you can observe this, the output voltage is increasing, right, as per frequency response. Again, for say 500 hertz, the output is 4 volt, right? For, you can observe the frequency here, right, it is approximately 600 hertz. For again higher frequency, let's say for 1 kilohertz. See, for 1 kilohertz again it increased and the output voltage is 7.6 volt, right? Again, I have increased this frequency to 1.5 kilohertz. Now the output voltage is 10 volt. Again, suppose I increase the frequency and I am increasing towards higher frequency, let's say 2 kilohertz, the output is 12 volt. Again, for increasing frequency, the output is 16 volt. And then for higher frequency, the output will be constant, let's say 16 volt, right? For the higher frequency, I have increased this frequency range and the output voltage is almost 1600 hertz. You can see the frequency range, right? So here, see, so for higher frequency, let's say 16 kilohertz, the output is approximately to 16 to 17 volt. So this is what the high pass filter is performing. So it's increasing, the gain is increasing, and then for particular frequency, means beyond the cutoff frequency of this high pass filter, the gain is constant, right? So in this particular experiment, as we have studied in the theory, the frequency response is flattened and it is a Butterworth filter, because in the pass band and the stop band, both the responses are flat. So this is a high pass Butterworth filter. Okay. So you just note down these readings from this video and you just fill out this observation table and do the calculation, right? Thank you.